Until this point, we have learned how to factor using GCF method, as well as factor trinomials where the leading coefficient was 1. In this case, we're going to put both of those ideas together, in which we look to see a trinomial and the leading coefficient is not 1. This is your first indicator to check for a GCF. So keep in mind when you're factoring, you want it first to be in standard form. So check that it's in standard form, meaning that the x squared comes first, then the x term, then the constant. Okay, then you want to check for a GCF. And then you are going to continue to factor. In this case, it'll be factoring a trinomial. Okay, so looking at our first example, you can notice right away that the leading coefficient is not 1. Since the leading coefficient is 2, we're going to say that our GCF should also be 2. You want to check, though, that 2, 20, and 50, that the biggest number they have in common is a 2. Since it is, I'm going to put a 2 first. And then in parentheses, I want to ask myself, 2 times what would give me 2x squared? So this should be an x squared. 2 times what would give me positive 20? So this should be a positive 10x. And 2 times what would give me 50? 25. Okay, you can also divide each of these terms by 2 and write the result in the parentheses. Now we are going to look on the inside of these parentheses, and we see a trinomial where the leading coefficient is now 1, and we can factor it the way that we learned in the last video. So we want to ask ourselves what multiplies to 25 and adds to 10. Things that multiply to 25 are 1 and 25 and 5 and 5. So it would have to be 5 and 5. So we'll do x plus 5. X plus 5. The biggest thing we don't want to forget is the GCF we originally took out needs to sit in front of this entire polynomial factored version. Okay. In this one, I don't even see what looks like a quadratic at first because I have an x to the third here. So the first thing I'm going to do is check for a GCF in the coefficients, which 2, 16, and 24 has a GCF of 2. But I also notice that I have an x to the third, an x squared, and an x, which means I can also take out an x as my GCF. So if I put 2x on the outside, I'm going to divide each term by 2x. Okay, or you can also ask yourself, 2x times what would give me x to the third? If I need x to the third and I have an x here, I'm going to need an x squared to get me there. 2 times what would give me 16? I'm going to need an 8. And if it's an x squared and I already have one x on the outside, I'm going to need the other x next to the 8 to get me to x squared. And finally, 24 divided by 2 would give me 12. Now I look on the inside of these parentheses, and I ask myself what multiplies to 12 and adds to 8. So I'll set up my frame, x and x. Things that multiply to 12 are 1 and 12, 2 and 6, or 3 and 4. So the one that adds to 8 would be 2 and 6, so plus 2, plus 6, and the GCF has to sit on the outside. So kind of your form should always be for these GCF and then the factors after it. Okay, we'll do one more example here. If I'm looking for the GCF here, the leading coefficient is not 1, so that's a good indicator that I need to check for a GCF. So my GCF is 4. That's the biggest number in common between 4, 4, and 80. I'm going to put a 4 on the outside of my parentheses. 4 times what would give me x squared? So I need an x squared. 4 times what would give me negative 4? So that would be a negative 1 and the x. And 4 times negative 20 would give me negative 80. So you can see here too, if I would have divided by 4 for each of these, that's also where these values come from. Then I'm going to ask myself what multiplies to negative 20 and adds to negative 1, which would be positive 4 and negative 5. If you need help factoring the trinomial that's inside here once you take off the GCF or take out the GCF, please watch the previous video on factoring trinomials where a is equal to 1.